Hello and welcome to this vodcast on the normal curve. Okay, so let's go through this rather quickly. We're going to start on this side of the page, okay? So the important thing to remember is that not all data forms a normal curve. But interestingly, a lot of large data sets, when we graph large data sets, they do form normal curves, okay? So for instance, height, intelligence of large sample sizes often form normal curves. Okay. Now, it's important to remember when you're going to be asked questions about data sets and what to do with data on the AP exam. If it has to do with the normal curve, they have to tell you that. That information is going to be provided for you, either by using normal curve, bell curve, or the data forms some type of symmetrical graph. Okay? So whenever we're dealing with data that forms a normal curve, the two very, very, very relevant and essential pieces of statistical information both come from what we would call descriptive stats. The first one is the mean, right, which is a measure of central tendency. The second one is standard deviation, which is a measure of variation or variability. Those numbers can vary depending upon the research done, right, and what's being studied. But all of that has to be provided. So you have three things that need to be provided for you. They have to tell you that the information does form a normal curve, and then they have to give you the mean and the standard deviation. Okay? Very few exceptions to that, but for the most part, let's stick with that for now. Okay, what will you need to do with this information, right? The application part. What are some of the most likely ways that they would assess how well you understand this? Okay, the first one would be this one right here. You should be able to create a line graph or a polygon based upon the fact that you know that the data is a normal distribution, forms a normal curve, and the mean is 52 and the standard deviation is 6. So the first thing I'd like you to do is please create a line graph or a polygon using this data. Mean is 52, standard deviation is 6, and the data forms a normal distribution, a normal curve, right? Normal distribution is probably the better word. Put me on pause and then do that, okay? All right, welcome back. Your graph should look something like this. This is the statistical symbol for mean. This is the statistical symbol for standard deviation. Okay, so your graph should look something like that. Notice that the mean is here. And then all we do to get this number, this number, this number, is we simply add 6. So we add 6 to 52 and we get 58. Then we add another 6 to 58 and we get 64. In this direction, we simply subtract 6 from 52 and we get 46, and then 6 from 46 to get 40. Okay? All right. Now, let's get into the questions that sometimes add a certain level of complexity for students. Okay? The second type of questions are also in blue. And these are the questions they'll ask you, and which I'd like you to actually do now. Okay? What percentages of score will? And there's numerous questions. I've only chosen 3. These are not the only 3 they can ask you. I've just chosen 3. What percentage of scores will? And then please answer this question, answer this question, and answer this question. Actually do it. Remember, be active, not passive, right? And put me on pause, okay, after you do those questions, and we can go over those. All right. So now, the important thing to know what the percentage is, right? We're going to be dealing with these questions. The important thing to know with these questions is that the percentages, when we have a normal distribution that forms a normal curve, the percentages are always set. These percentages never, ever change. You just simply have to memorize them. They just are, okay? So basically, let's fill this graph out a little bit more, though, to help us. We always make the mean 0 for some reason when we're dealing with standard deviations, because this line over here is going to be our little cheat sheet about standard deviations. Scores that are directly to the right of our mean, we say are 1 standard deviation above the mean, right? This score then would be 2 standard deviations above the mean. The 70 would be 3 standard deviations above the mean. When we go towards the left of the mean, we're dealing with, this is 1 standard deviation below. The 40 would be 2 standard deviations below the mean, and 34 would be 3 standard deviations below the mean. Okay. The percentages that are in these areas always stay the same. So what percentages of scores fall within 1 standard deviation? When they say 1 standard deviation, what they mean is between this and this. So 1 standard deviation includes above, sorry about this pen, and below. All right? So above and below. It includes everything from here to here. So all you do is you simply add 34 and 34. So the answer to the first question is 68%. The second question right here asks what percentages of scores will fall 1 standard deviation above the mean, right? So remember both of these, right? This is above and this is below. That's for the first question. But now I'm asking you a very specific question above the mean. 1 standard deviation above the mean. So you just go there and then you look at, what's between this line and this line? 34%. Okay? What percentages of scores fall within 2 standard deviations from the mean? So remember, within 2 has to mean 2 above and 2 below. Same rule as when we're doing 1. So everything from here, 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 and here. So all you do is add 13.5, 34 plus 34 plus 13.5. And the answer is 95%. Okay? So that would be the answer to number 3. Now, the other questions they can ask are in the red. It should be what, not how, sorry about that. What percentage of people will score between A? They're always going to give you scores. When you're dealing with a normal curve, they're always going to give you the scores that you graphed here. 34, the 40, the 46. They're always going to give you those scores, okay? They're not interested in trying to trick you or having you do any type of intricate statistics here. So what percentage of people will score between a 46 and a 52? Well, 46 and a 52, this line to this line, that's 1 standard deviation below, 34%. Which percentages of people will score between a 40 and a 52? So you go from here to here. 34 plus 13.5, right? So you just 34 plus 13.5, right? And you just do the math, right? 47.5. Check my math to make sure it's correct, right? But that's what you would do. So all the scores between here and here, 13.5 and 34. What percentages of scores between 52 and 64? So same thing, you would add this and this, right? And you get your percentages. And by the way, this little thing is 2% of the scores, right? I just couldn't fit it in there. That's how you do the normal curve, okay? Those are all the questions that they would ask you. This is very important, right? When they say 1 standard deviation, it includes 1 standard deviation above and below. They will always specify if they just want you to do this portion, that's 1 standard deviation above, okay? And you can fill in any number, right? You can put in 3 and put in 3. Those are your basic rules on how to do normal distribution.